Hello, welcome to the first of a series of videos where we will be learning Python for data analysis. So, as we go along in this video session, you should code along with me. So, don't just watch the video, try to code along as I'm coding as well. And pause the video if you need to, but try to be actively engaged. Okay, so in this first lesson, we'll start a little bit basic. We will start off looking at variables, creating variables, listing, deleting variables. We will begin looking at lists, which are used a lot in Python. And we will start just a small introduction to arrays. And then we will have an exercise at the end, or you will do an exercise at the end. Okay, so setting variables. Variables. So in setting variables, we use this operator, the equals to, the assignment operator. Um, so like we saw last week, you can set x to be equal to 2, y to be equal to 3, and you can do some arithmetic operations on these variables, and I can print the output of these variables. So if I run that, you can see x was 2, y was 3, the sum of that was 5, and that has been printed. You can also do other things such as using other mathematical operators like the square root or the square. Um, so first of all, I will import. I like to import at the top of the um, notebook. You don't have to do this, but I think it keeps everything tidy to import everything at the top. So I'm going to import this module math. So I have math there, and I'm going to set z as the square root of x squared plus y squared, and I'm going to print z. So I end up with 3.6, which is the square root of x squared plus y squared. So you will also notice when you use Python that Python is a dynamically typed language. What that means is, initially we can set x to be an integer 10, going to print x, and then we might later on change the value of x. So phi, phi, fo, fom, and print x, and you will see um, Python has allowed us to dynamically change the type of this variable. Here, this was um, an integer. Now this is a list of strings. So that has been changed. You can also do type conversions. So here, if I say print x, type x, so initially x was an integer, now it's a list. We can convert from one type to another, and this is necessary sometimes. So uh, you might have a number. Usually when you read into, maybe you read some number in from a file, it might be coming as a string. So this is a string. Anything in quotes is usually is a string. And if I try to multiply or find the square root of this string, I will get an error. So it will say type error, must be real number, not string. So if you have this scenario where if you have this error, what you can do is convert this. I will just call it new or converted number. You can convert this to a floating point number, which is like a regular decimal number. So the original number was 2.14. I have used this type conversion to convert it to a floating point number that I can use. So you can see it's a floating point number now. And I can do the square root now. I can do some mathematical operation. Other type conversions that you can do. If you have, let's just call this num2. This was 3. You can use the int keyword to do the type conversion. And you'll be able to do some sort of numerical operation now on this. So we've converted this string to an integer, and now we can do some operation on it, arithmetic operation. And you might also need to convert a number to a string. Here you use the str keyword. And sometimes this is useful if you want to save this to a file on your desktop, like a text file. Uh, Sometimes you have the function you use might convert it for you, or you may have to convert it yourself. So you may need to use the str keyword. So this is just a little bit on type conversions. And if I print the type now, you can see it has been converted to string. Before it was an integer, now it's a string. Okay. So listing variables. In Python, if you want to see all the variables that exist in your workspace, your current namespace, you can use the dir function. In this case, you will end up with not only your own user-defined functions like num, num2, num3, xyz, but you will end up with all the Python internal um, variables. So user-defined variables, you can use vars. Um, or a more a more a better way of doing this so you don't see all this. Let's say dir, you can use what is called list comprehension. So we will say we'll go through list comprehension later on, but var, we want a variable for all the variables that exist. Um, if not, var dot starts with this underscore. So all these underscore things that belong to Python, we are filtering them out. So if the variable doesn't start with an underscore, we filter it out. So now we can see some of our variables along with some of the functions we imported. So this is just a way of looking for trying to keep track of variables that you may have in your workspace. And you may also want to delete variables. So you should be careful about this. So let's say we have some variable x is 2 times pi, math.pi, and we print x. So pi is 3.14159. Twice that is 6.28318. We could delete using the del keyword x. Anything you see show up in bold green is a keyword. So it's a reserved keyword. You can't use this for your own for your own variable name. So if we delete x and then try to print x, we get an error because x has been deleted, so it's not defined. Okay. So this is just an introduction on some of the things you may have to do with variables. And you will do more practice as time goes on. You'll see more of this in practice. Okay, so let us move on. So we're going to create a list or an array. We're going to start off with lists and see what lists can do. Um, so you can create a list in several different ways. Okay, I can say list1 equals You can create a list of integers 2, 3, 4 and print list1. You can create a list of, say, list2 containing strings A, B, C, or A, B, D, G, H, I, cow, COW, list2. And we can create a list, containing Boolean values as well. True, false, false, true. And we can even create lists where the types are mixed. Oh, list 3 is not defined here. Okay. So, and we can create lists where there are mixed types, so strings, integers, and so on. You can combine lists. So combining a list is different from adding or subtracting the list. So let's say call this V1 equals 1, 2, 3. V2 equals 4, 5, 6. Combined equals V1 plus V2. And when you print combined, you see the list has been joined. If you want to do the actual addition on that, that's more of a different approach, which we will see later on. But you can combine lists. So if you have two lists and you want to concatenate them together, you can combine them. You can compute some basic statistics on a list, mean, median, standard deviation. In this case, we are going to use the NumPy package. So I will go up here. I like to import everything at the top. You can import it wherever. Import NumPy as NP. So I have some data. Let's say X is a list 2, 3, 50, 66, 78, 0, 9. And I have Y 1000, 2309, 440, 4047, 1267. The mean, so the mean will be given, you can use the np.mean function. You can print the np.mean np.median of X of what we want to compute. We could print the np.variance, np.var x. Uh, Sometimes in Python, you need to set the degrees of freedom. If you want to know what options there are with a function, so np.var, you can see the options that exist here, or even better, you can go to the documentation. So there is a site, the NumPy site, where it tells you, let's say we want to find the variance. We want to find the variance of A. So this is the list that we passed in. You can specify the number of degrees of freedom. You can specify the data type, and so on. And what this means is given here in the documentation. So with NumPy, there is a good site that you can, if you're not sure what the options are that are available, you can look in the documentation. Okay, and then um, np.mean of y. So we have all these numbers, so we can do at least some basic statistics using this NumPy package. Okay, so another thing that is useful is creating sequences. So creating sequences, you can use the range function. Okay, so how this works is, say I want to create a list containing numbers from 1 to 5. So this is a list range. I have to print this. No, there's an extra bracket, I think. No. List range 1, 5. Okay, so there was an error. I had an error with the list. I created a variable somewhere. So I have deleted that, and now I can print my sequence. So here, you can create a range object, from 0 to say 10, and you will see that what happens. I put this in a list. You will see what happens is it goes from 0 to 9. So this bound here is exclusive. So it will go from 0 to 9. Same way this went from 1 to 4. So when you use the range function, you should be aware of that. We don't have to start from 0. We can start from 10 to 20. Okay, so we go from 10 to 19. We could go from So we can go from, let's say 1, we want to go to 20. So we'll put the upper bound of 21, but we want to go in steps of 5. So in steps of 5, we start with 1, we add 5, we get 6, we add 5, we get 11, we get 6. We get 11, we add 5, we get 16. So we can go in steps of 5. We can also do this backwards. So we can go from 9 to 0. In this case, we will use the bound of -1. And because we're going backward in steps of -1. So you can see we go from 9 in steps of -1 to 8 to 7 to 6 to 5 all the way to 0. And then -1 is the lower bound, is the bound. So this is quite useful. And then you can also repeat a list, multiple times. So say multiply. I want 1 5 times in the list. This is one way if you need to create a list that's full of ones or full of a particular value, you can use this shorthand. You can sort lists as well. This will be very useful. So say numbers equals 64, 25, 12, 22, and 90. So you can use the sort function. So let's print the original set of numbers. Then we use the built-in sort function. So we type in numbers dot sort, and let's print numbers. So originally we had this in some random order, some order it came in. Then we've sorted, and now it's going from low to high, 12 all the way to 90. We can do this so that it is sorted in descending order. So numbers dot sort, and then we will use the option reverse equals true. And if we print numbers, now it's going from the highest number to the lowest number. You can also do this with string values. So fruits, say banana, apple, date, kiwi, um, fruit dot sort, print fruit. It has sorted this in alphabetical order. So you can do this as well. Okay. So now we will look at comparing values. So to compare, there are a few symbols that are used. Okay. To see if two things are the same, let's create two things. I'm just gonna call this x. Let's say x equals 5, y equals 10. So to compare if they're equal, we use the double equal sign. So we should be aware of this. Sorry, print is x equal y. Essentially, this is what we're asking. Is x the same as y? Um, so if we want to compare if they are equal, we use the double equal sign. So is x the same as y? False. Um, is x greater than y? False. That's the greater than sign. Is x less than y? True. Um, is x less than or equal to y? True, because it is less than. Is x greater than or equal to y? False. So these are how you compare two different values. You use these operators. So equals equals for the same, and then greater than, less than, greater than or equal to, less than or equal to. And you will get a Boolean value telling you whether what you're comparing is true or false. Okay. So we have compared individual values. You can also compare lists. Okay. So let's say I have a list here, 3, 4, 5. Another list here, 3, 5, 4. Standard list comparison. Is x the same as y? It tells me false. Is x not equal to y? That says true. Um, greater than, less than, you may want to start looking at element wise comparison. So element wise comparison, with lists, you have to use the zip function. So first of all, zip, what does zip do? Let's start zip xy. So it gives me an object, some object there. So zip, we've zipped x and y. So what this has done is it has created um, a list containing the corresponding indices of x and y. So first for x, 3. First value for y is 3. It has put that in a tuple in this bracket. So that is the first. Um, it has combined this 4 with 5 for the second item, and then 5 with 4 for the third item in that list. So you would have to do, if you wanted to do element-wise comparison with lists, say what you would do is say, is A equal to B for A, comma B in zip x, comma y. And then what that does is tell you, so here is A and here is B. and it's saying is A equal to B. So it will do that for every tuple in this list that the zip created. So is A equal to B? True, because 3 equals 3. Is 4 equal 5? False. Is 5 equal 4? False. Um, you know, you could also do, I'll just copy this. Um, is A greater than or equal to B? True, false, true. Is A not equal to B? False, true, true, and so on. So this is how you can do element-wise comparison of lists. Now, it might be easier. It might be easier if you have to do element-wise comparison to use arrays. So we will first of all just start looking at um, one-dimensional arrays. And next week or the next video, we will look at um, multi-dimensional arrays. So here, um, I'm going to use the NumPy package, the array function, and I'm going to create this simple one-dimensional array. It's one-dimensional array because there's only one row. If we had rows and columns, multiple rows, multiple columns, we would be looking at multiple dimensional arrays, but here it's quite simple. So X is going to be an array. We're going to use an array instead of a list. 3, 5, 4 for Y. And now I can simply just ask, is X equal Y? So I didn't have to do this zip operation. I can just directly compare element by element. Is X greater than Y? False, false, true. We can also do element wise arithmetic. So I have one array, V equals 11, 12, 13, 14, 15. W equals 1, 2, 3, 4, 5. And I can print, V plus W. Ooh. np.array. Okay. These are lists. So it has concatenated these lists. If you wanted to do element-wise arithmetic with lists, you would have to use a for loop or something. So here with arrays, okay, I put that in an array. Aha. So now 11 plus 1 is 12, 12 plus 2 is 14, 13 plus 3 is 16, and so on. 15 plus 5 is 20. So this is much easier than using a for loop, which we will look at in a subsequent video. So V minus W. Okay, 10, 10, 10, 10, 10. V times W. So 11 times 1 is 11, 12 times 2 is 24, and so on. 15 times 5 is 75. V divided by W. Again, element wise. Um, and then, just like before, you can find the mean of this array. So in this case, it is 13. And then you can do the standard deviation and so on. Okay. So selecting array elements, I have a list here. I'm going to say a list of the Fibonacci numbers 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. As a list, I'm going to put it in a simple array. np.array fib, and I could just print fib. So, fib array. So this is an array. So I can select elements. So again, we start counting from 0. We start indexing from 0. So the first item is the 0th index. The second item would be the first index. So 0, 1, 2, 3, 4, 5, 6, 7. Fib array of 7 would be 13. So we start the 0th item, the first, second, third, fourth, fifth, sixth, 7th item. We could select from the 7th to, say, the 10th item. So we can start from the 7th item. We use this colon sign to tell us where we want to go. So this is the 7th, the 8th, the 9th, and this bound here is exclusive, so it won't give us um, the 10th index. It's just like we saw above. Okay. Another thing to cover are dictionaries. So dictionaries are very useful. Um, they are defined using these curly brackets, and usually you'll see um, they are written. There's a key that corresponds to a particular value. 1998. You don't have to put them on multiple lines. You can have them on one line. So France won the World Cup in 1998. Brazil won the World Cup in 2002. Italy won the World Cup in 2006. Spain won the World Cup in 2010. And Germany won in 2014. 614. Okay. So in this dictionary, um, you have an item, so a key and a value. So you have key value pairs separated by commas. So the key would be France. The key can be a string, it can also be an integer. The value can be anything, it could be a list, it could be a string. Um, but it's very useful because if you want to find the years that Brazil, or the year in our dictionary that corresponds to Brazil, you just type in year of Brazil. So you can access these values by using the keys. So the key here is Brazil. Um, you can say years, Germany. It doesn't really matter, but let's say I put this in a list. So years of Brazil, years of Germany, and that will return the values that correspond to these keys. So 2002 corresponds to Brazil. This value 2014 corresponds to the key Germany. Okay. Second to the last thing before um, something called operator precedence. So you may have seen, you will have seen this a long time ago, but 2 plus 5 times 10 is what? Um, it depends on how you order it. So you could say um, 2, if you just typed it in, 2 plus 5 times 10, it give you 52 because it does the multiplication first. Um, if you want something specific, just use brackets to tell Python exactly what you want specific. So if you want to do this sum first before multiplying by 10, um, you need to use brackets. So Python will evaluate what's in brackets first of all and to work from the inside out. So the easiest thing to do if you're not sure whether the multiplication will be evaluated before the addition or vice versa, just use brackets to group together what you want, and then Python will work from the brackets and then move outwards. Okay, so the last thing we will look at um, will be displaying data from a file. In this case, we are going to use a CSV file. But if once you know how to work with CSV files, um, you can work with other files once you get used to working with CSV files. So what we are going to do, what we need is the pandas um, package. So I'm going to import pandas as PD. Okay, and that's really useful for working with files. Okay, so I will say I have some data. I'm going to call it price data. We will look in the next video at arrays in more depth, at data frames in more depth. But just to introduce the concept, we're going to read from a CSV file. So this is a CSV file. You know, you can also read from Excel files, XML files, JSON files, but this is a CSV file. We have one column oil and one column with gold prices. So I'm going to read underscore CSV, and then in quotes, the name of my file was oil gold, and then file extension CSV, the type of file it was, and file not found. Okay, oil golds, OILGOLD. Okay, so the file is not found because I am not working in the same directory, the same folder where oil gold is. I was working in this folder mistakenly. So this is the notebook I'm using here. And there is no CSV file in this folder. So what I'm going to do is go to the location where it is. You can see there. I'm going to click on the dots and I'm going to copy path. So I have copied the path, the full location to where the file is. And instead of typing in oilgold.csv, I will paste the full path, which can be long. So usually it is advisable if you're working in a folder, a specific folder, have your data in that same folder so you don't have to use this whole long path. And you will see if I try to run this, there will be an error because of all the black slashes. So what I can do is put an R in front of the full path, and that should give me my that should it should access where the folder, the file I'm trying to read is. So I will just type in price data. This is a data frame. Okay. We will look at data frames in the next video. So it has read the CSV as a data frame. If you really just want to see the first few rows, you will use the head command. So price data.head will give you the first 5 rows. If you wanted to see the first 7 rows, you would type that in there. So I want to see the head, price data.head. We can select each column using the name of the column. So here, price data, the oil column, I've typed in oil. It has given me the oil prices on that column. Um, and I can do the same for gold. You can do the same for gold. You can do some statistics. In this case, Pandas has built-in mean and median and mode and variance correlation functions in there. So if I wanted to find the mean of all these prices, um, I would just use mean, the mean function, the built-in mean function. So I would type in price data of oil dot mean, and it should give me the mean of these. And that's the mean. I can type in the median, and this is the median. Okay, so this is all for this first video. Just a basic introduction into most of the things you will be using. Next video, we will go more in depth into arrays and data frames, which you will be using. So now there's an exercise for you. So here is the exercise. My neighbor Alice has 7 children with the ages 18, 13, all the way to 22. So one, you create a list to store the ages of my neighbor. Now you can see the ages here are not in ascending or descending order. So sort the list in descending order. Uh, find the sum of the ages of my neighbor's children. What is the average age of her children? What is the standard deviation of their ages? What is the age of her fourth child? What is the difference between the ages of her first and fifth children? And what is the difference between the ages of her second and seventh children? So you should be able to do this just using the list functions that we looked at. Okay, so have a go at this, and I'll see you in the next video.